All right. Good day once again. Welcome to Success Enlightenment. I'm Ishola Adedeji Michael, and we are still on our what? Our probability distribution. All right. Um, this will be the fifth question we are going to be solving on probability distribution. This is a simple is a question. All right. We have a question, and we want to solve it. We want to know how to go about the question. All right, let's see the question and let's see how we go about it. Okay. All right. The very simple question, straightforward and direct. We're asked to find the probability of obtaining a sum of C's by tossing a pair of dice. All right, that's the first question. All right. That's in pretty straightforward. And the other one, they give us a what? A binomial distribution formula, and we're asked to find the probability where s equals to 0, s equals to 1, s equals to 2 is n is equals to 4. And the last one, we have to find the probability that a student can guess correctly the answers to 12 or more out of 20 questions in a true or false test. All right. Without much of talking. All right, let's go straight into solving this question. If this is the first time you coming across this channel, or you've been on this channel but you are here to subscribe, please do me the favor of what? Of hitting that subscription what? Notification. Please subscribe to the channel, and also feel free to engage me. Every thumbs up you give for any of my video, I'm expressing my honest word thank you to you guys. All right, now let's see how this question, let's see how it goes. We are asked to find the probability of obtaining a sum of C's from the tossing of a pair of dice. Right? When you hear that a pair of dice is toast, like that means you toast two die. Like that's the meaning of a pair means two. So now the first thing you have to do is conduct your experiment. Right? If you're conducting your experiment, it's best in this scenario you use the table to conduct your experiment for conveniency. All right. The first die we have one, two, three, four, 5 and 6. Okay, that's what we are going to have in the first die. All right, this is what we are going to have in the first die. Okay, all right, the second die we have one, two, three, four, 5 and 6. Okay, okay, okay. Let's form our table first. All right, now let's toast. If you toast the first die, now what are the possible options we can have? Here we can have the two dice showing one and one. You can have one and two. You can have one and three. You can have one and four. You can have one five. You can have one six. You can have one seven. Sorry. We can have one six. Then we can have two one, two two, two three, two four, two five, two six. We can have three one, three two, three three, three four, three five, three six. We can have 4 1, 4 2, 4 3, 4 4, 4 5, 4 6. Can have 5 1, 5 2, 5 3, 5 4, 5 5, 5, 6. We can have 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. All right, this is the result from the random experiment of tossing a pair of dice. Now let's, how many, what's the total outcome that we have from this? Total outcome we have from this, if we count all every possible response from this random experiment, total outcome we are going to find from this is what is 36. Okay, that's total that we are going to find from here. That's 36. That's the total. Right now, from here we have to know how many times do we have a sum of what, of figures that make a 6. Yeah, we have to find sum of 6. All right, so let's ring the sum of 6. Let's mark the sum of 6. 1 and 5 is 6. This 1 and 5 is 6. 2 and 4 is 6. 3 and 3 is 6. 4 and 2 is 6. 4 and 2 is 6. 5 and 1 is 6. All right, beside this there is no any other outcome where we have what, say sum of two digits that give us what, 6. So if you count the total that we have that give us 6, they are 1, 2, 3, 4, and 5. So we have what, 5. We have 5. We have 5. So therefore the probability of x, probability of x, probability of x equals to sum of 6 will be equals to what, probability of having a 1 and 5 outcome. Sorry, that's a mistake. We're having a 1 and 5 outcome, 1 and 5, or probability of having a 2 and 4, we're having a 2 and 4, or probability of having a 3 and 3, or probability of having a 4 and 2, or the probability of having a 5 and 1. Now probability of having 1 and 5 there is 1 over 36, or means plus 2 and 4 is 1 over 36, 3 and 3 is 1 over 36, 4 and 2 is 1 over 36, and what, 5 and 1 is 1 over 36. When you add all this together is what, you give us 5, you give us, to give us 5 all over 36. All right, this same thing as just go to the table and find how many times does your result gives you the two figure that when you add together it gives you 6. Those are the sum of 6. And whatever you have there, which is 5, divided by the total possible outcome, which is 36, that's the probability of having a sum of 6. And that is that about that. Let's progress in solving the next part of the question is we have to find f of x such as n combination x uh n combination x p of x q of n minus x. Okay, where our x is equals to 0, 1, 2, and our n is equals to 4. Okay, and our n is equals to 4, and our n is equals to 4. All right, we are to draw this based on the earlier solved the question. This is the as a random experiment of tossing a pair of die. So now it is from the success or failure of tossing the pair of die that we are to come around with our word to find the probability of success and the probability of what of failure. Right? The probability of success there of having a sum of a sum of a sum of 6 as calculated earlier. All right, the probability of success from having a sum of 6 as calculated earlier is what is p, and that's what 5 all over 36. Why the probability of failure probability of failure will be what, that will be 1 minus 5 over 36, which is then equals to what 36 minus 5 over 36, therefore is equal to what 31 all over 36, 31 all over 36. So therefore our q probability of failure is what 31 all over 36. Don't forget, you are asked to use the calculated probability in the first question to solve the second question. This is, you already find the probability of success. All right, that's what you calculate, which is 5 over 36. Now use that to find the what, the if the try is what is zero try, one try, or second try. All right, so with that being with that already in mind, so what we simply do here is what we do, our formula already have everything we need, so we just insert the variable in our formula. All right, so here now p of x equals to what 0. Let's do p of x equals to 0. That will be 4 combination what is 0. Probability of success is what 5 over 36 raised to power is 0. Probability of failure is 31 over 36 raised to power what 4 minus 0. 4 minus is 0. Okay, all right. Now 4 combination 0, that will be what 4 factorial all over what 4 minus 0 factorial is 0 factorial times anything raised to power 0 is equals to what 1. So times what 31 raised to power 4 all over what 36 all raised to power 4. Okay, All right, so from here now, we have 4 factorial. This will be what? 4 factorial all over 4 factorial times what is 31 raised to power 4? What is 31 raised to power of 4? That will be 31 times 30, 31 times 31 times 31 times 31. That will be 9, 2, 3, 5, 2, 1. Now, what is 36 raised to power 4? Now, 36 times 36 times 36 times 36. All right, that's a million plus. That's 1679 616. This we cancel this. So therefore, our probability of s equals to 0 will be what? Will be 923 521 divided by 1679616, and that will give us 0.5 approximately. So probability of our x equals to is 0 will be what? 0.55, or call it what? 55 percent. All right, or call it what? 55%. All right, so that's in our in zero try probability, that in zero try probability that what we have there, we don't have the sum of c's there is what? 0.55. That's that about that. Now what about probability where of s when s equals to 1? When s equals to 1, when s is equals to 1, so this p of x is equals to 1. So that will be what? 4 combination 1. Probability of success is 5 over 36. Now 5 over 36, that will be raised power 1. Probability of failure is 31 over 36 raised power what? 4 minus 1. Right? So what is 4 combination 1? That will be 4 factorial all over 4 minus 1 factorial 1 factorial times what? This is 5 over 36 times this will be 31 raised to power 3, because 4 minus 1 is 3. That will be 31 raised to power 3, and that's will be equals to 29,791. 29,791 divided by 36 raised to power 3. That will be 36 raised to power 3, which is 46,656. That's 46,656. All right, now, so from here now, what do we have? All right, let's look at the our 4 factorial. So this is equals to 4 times 3 factorial all over what? 3 factorial. All right, this we cancel this, we have 4 less, times what? 5 over 36 times 29791 all over 46 over 656. All right, so just press your calculator. You having 4 times, what is 5 over 36? What is 5 over 36? All right, 5 divided by 36. 5 divided by 36, that will be what? Is 0.139. What is 29,791 divided by 46,656? All right, 656. That will be 0. That will be 639. All right, when you multiply all these together with your calculator, what does that give you? This will give us 4 times 0.139 times 0.639. This will give us what? 0.035. Let's 355. That is the probability of um having a sum of 6 in two tries out of 4 is what? Is 35.5%. 35.5 in percentage. All right. Also we are asked to find when s is equals to 2. All right, in two try we find 1, we find 2. So let's see when we s equals to 2. So we're calculating for what? P x equals to 2, and here we'll be having what? 4 combination 2. Our probability of success is 5 over 36 raised power 2. Probability of failure is 31 over 36 raised power what? 4 minus 2. Okay, so here we have what is 4 combination 2? That will be 4 factorial all over what? 4 minus 2 factorial, 2 factorial, times 5 raised to power 2. That will be what? 25. What is 36 raised to power 2? That is 36 times 36. What's that? That's 1296. That is 1296 times, what's 31 raised to power 2? That's 31 times 31. That's 961 all over 1296. This is because 4 minus 2 is equals to 2. All right. 4 factorial, we have 4 factorial all over what? 2 factorial, 2 factorial. Okay, which is same thing as this 4 this is 4 times 3 times 2 factorial all over 2 factorial, 2 factorial. 2 factorial counts 2 factorial. Then we have 12. Then we have 12. 4 times 3 is 12. 12 divided by 2 factorial is empty as 2. So therefore, this is equals to 6. This is equals to 6. So now we can compute everything. Now we can use our calculator and find the exact figure we are looking for. So we have what? 6 times, what is 25 divided by 1296? 25 divided by 1296, that will be 0.019. Also times, what is 961 divided by 1296? That will be what? Is 0.742. All right, so when we multiply all these together, what do we have? Multiply all these together, we have 6 times 0.019 times 0.742. All right, so what we have is what? We have is 0.085. It means that the probability is what? Is 8.5%. So therefore we'll be able to calculate the probability of when s is equals to 0, when square is equal to 1, and when s is equals to 2. All right, that's the second task we are asked to perform in this question. All right, we've gotten to the last part of this question here. The last part of this question is we have to find the probability that a student can guess correctly the answer to 12 or more out of 20 questions in a true or false. To do this, what we do is very, very simple. To do this, we do is very simple. Now we have to first get what is our n. What is our n from what we have there? Now from what we have here, our n here is what? Is 20. We say total of what? 20 questions. All right, that question is what is 20. Okay, our n is what is 20. All right, now our x that we want to find, our x is 12 or more. That is, our s is greater than or equals to 12. Our s greater than or equals to 12 in a true or false question. So the probability of success in such will be what? Will be 1 over 2, and probability of failure will be what? Will be 1 over 2. So having getting this from the question given now, we can go ahead and we can solve this question using our binomial probability distribution formula. Okay, using our binomial probability distribution formula. So the first we are going to find is p of x equals to greater than or equals to 12, right? That we are asked p of x greater than or equals to 12 equals to what? P of 12 plus probability of p of 13 plus p of what? 14 plus p of 15 plus p of 16 plus p of 17 plus p of 18 plus p of 19 plus p of 20. Okay, plus p of 20. That's probability of s is greater than or equals to 12. All right, we are going to find this one after the other. All right, that's probability of s greater than or equals to 12, and we have to what? Sum it together. We have to what? Sum it together. All right, so when we add it together, that's the probability of what? S greater than or equals to 12. Okay, so let's go ahead and get right into it. What's probability of s is equals to 12? So p of 12, let's do p of 12 first. P of 12, that would be what? 20 factorial all over what? 20 minus 12 into 12 factorial. Probability of success is 0.5, which is the same thing as 1 over 2 raised to power 12. Probability of failure is also 0.5, which is raised to power that would be 20 minus 12, that would be what? 8. That would be 8. So 20 factorial all over, that would be 20 times 19 times 18 times 17 times 16 times 15 times 14 times 14 times 14 times 13 times 12 factorial times 12 factorial. All right, everything divided by everything divided by everything divided by 8 factorial, 12 factorial. All right, this 12 factorial we cancel 12 factorial. 12 factorial we cancel 12 factorial. Now the question is, what is the product of 20? What is 20 times 19? 20 times 19 times 18 times 17 times 16 times 15 times 14 times 13. That will be 5 million is 079 110 400. I mean 5 billion rather. All right, so all these are, we'll be dividing this by what? 8 factorial. We divide it by 8 factorial. Now what is 8 factorial? 8 factorial will be what? 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So, and that will be what? 5079 110 400, all divided by what? What is 8 times 8 times 7? 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That will be 40 4320. And when you divide 5079 110 400 divided by 4320, all right, what you have left will be what? What you have will give you, that will give us 125970. All right, that is the factorial part, the factorial part. So now we want to find what is we want to find what is 0.5 raised to power 12 as well as 0.5 raised to power 8. Don't forget the real answer we are looking for, which is probability of 12. That will be what? 125, sorry, that will be 125, that will be 125970 times 0.5 raised to power 12 times 0.5 raised to power 8. Okay, so we can quickly do this using our calculator. All right, 0.5 raised to power 12, 0.5 raised to power 12, that's 0 point, that will be 0.0000244. This times 125970 times what is 0.5 raised to power 8. So 5 raised to power 8 will be what? Is 0.0333906. 3906. All right, so from here we can press this directly on our calculator and let's see the figure. Let's see what our final answer looks like. All right, we have is 0.003906 times 1259790 times 0.000244. All right, so the answer this give us will be what? Is 0.1201. Right, this probability of 12. Also we are going to find this, we do the same thing, find probability of what? Of 13. We are going to do the same thing, find probability of what? Of 13, p of 13. All right, I also do the same thing, find probability of what? 13. So p 13, this will be what? 20 factorial all over what? 20 minus 13 factorial 13 factorial times what? 1 over 2 or 0.5 raised power what? 13. 0.5 or 1 over 2 raised power what? 13. 20 minus 13, that's what? 7. All right, so from here let's find the factorial part first. This will be 20 times 19 times 18 times 17 times 16 times 15 times 14 times 13 factorial 13 factorial all over 20 minus 13, that's 7. That's 7 factorial 13 factorial 13 factorial. Alright, this 13 factorial will cancel 13 factorial. So what we do simply is what we work with our calculator and find what is what 20. Don't forget 7 factorial will be what 7 times 6 times 5 times 4 times 3 times 2 times 1. 7 times 6 times 5 times 4 times 3 times 2 times 1. So now if we put this on our calculator, what do we have? This will be what 20. This will be 20 times 19 times 18 times 17 times 16 times 15 times 14. And this will be 390 million 390 700 800, all divided by what is 7 times 6 times 5 times 4 times 3 times 2 times 1. That will be what 5040. So now when you make the division, what do you have? We have 390 700 800 divided by what 5040. So what do we have? That will be what? That will give us 77520. Now what is 0.5? Don't forget what we are really looking for. What we are really looking for is what is p of 13. That's p13. That's 77520 times 0.5 raised to power 13 is 0.5 raised to power 7. So this our calculator can help us with it. What is 0.5 raised to power 13? Now is 0.5 raised to power 13. That will be 0.0000122, all right, times 77520 times what is 0.5 raised to power 7? That will be 0.00781, right? 781 781. So when you do this multiplication using the calculator, what do we get? When you do this multiplication using the calculator, what do we have? That's 0.00781 times 77520 times 0.0000122. All right, that gives us what? 0 point that gives us 0.039. All right, 739. This is the probability in 13. So now we keep on calculating till we get to what? We get to the last one, which is 20, and we are going to add all these together. We are going to have all these together, all right, because we are finding the probability of 12 or more. All right, so let's quickly do the what? The 14. What do we get for 14? What is p of 14. All right. So P of 14, P of 14, that will be 20 times 19 times 18 times 17 times 16 times 15 times 14 factorial, all divided by 20 minus 14. 20 minus 14 will generally give us 6 factorial. 14 factorial. 14 factorial will cancel 14 factorial. 6 factorial is same thing as what? 6 times 6 times 5 times 4 times 3 times 2 times 1. Okay? Everything here will be multiplied by 0.5, which is probability of success. 0.5 raised to power of 14, raised to power of 14 times 0 point, sorry, times 0.5 raised to power 6, raised to power 6. All right, so let's get on to our calculator and let's see what we get when we multiply all this. So what we have 20, 20 times 19 times 18 times 17 times 16 times 15. All right, 20 times 19, 18, 17, 15, and 16. That gives us, that's that gives us 27907,200, all divided by, what is 6 times 5 times 4 times 3 times 2 times 1? That give us what? 720, multiplied by, what is 0.5 raised to power 14? 0.5 raised to power 14, that will be what? 0.00061. Now what is 0.5 raised to power of 6? 0.5 raised to power of 6, 0.5 raised to power of 6, that's is 0.12, sorry, 0.1, 0.0 rather, 0.0156, that's 0.0156, that will be 0.0156. All right, so from here, let's get to our calculator again. Let's do the multiplication and let's see what we have. So first, let's do the division first. We have 279, we have 27907,200 divided by 720. That give us what? 38 7, sorry, 38,760 times, what's the product of 0.00061 times 0.00, sorry, 0.0156. Okay, yeah, this times what? 38760. All right, 38760. All right, let's do the product all together to just save our time. When you multiply everything you have here all together using your calculator, so your probability will be what? 0.0369. This is what your probability will be. All right, we successfully find the probability of of 12. Successfully find the probability of 12. We have found probability of 13. We have found probability of what? Of 14. Now let's find probability of what? 15. Okay, let's find probability of what? 15. P 15. Okay, that will be 20 factorial. That will 20 times 19 times 18 times 17 times 16 times 15 factorial. Now 15 factorial, all divided by what? 20 minus 15, that will be 5 factorial times what? 15 factorial. This cancel this. This cancel this. Okay, 15 cancel 15, I mean 15 cancel 15. We have here, we have 0.5 raised to power 15. We have here 0.5 raised to power 5. 0.5 raised to power of what? 5. 0.5 raised to power of 5. So now we turn to our calculator. We turn to our calculator and see what we can get. All right. So we multiply 20 times 19. Multiply 20 times 19 times 18 times 17 times 16. So that give us 1,860,480. So what is 5 factorial? That's 5 times 4 times 3 times 2 times 1. So that's 120. All right, times what is 0.5? 0.5 raised to power of 15. Raised to power of 15, that is 0, sorry, that's 0.00031 times what is 0.5 raised to power of 5. That's 0.03125. 3125. Okay, now from here directly we can use our calculator. Our calculator can give us direct answer here. We can find our probability of our our 15 here directly. So if you press our calculator, we have 1 8 we have 1,860,480 divided by 120. That's 15,504 times 0.00031 times 0.03125. So our probability will then be what? 0.015. Okay, 0.015 approximately. That will be our probability. That will be our probability. So now we've gotten for 15, so we have to get also for 16, 17, 18, 19 and 20. All right, so now from here let's get for what? 16. Let's get for 16. Okay, let's go ahead and get for 16. Now 16, p of 16, that will be 20 factorial, which is 20 times 19 times 18 times 17 times 16 factorial, all over 20 minus 16, that will be 4 factorial. 16 factorial. 16 will cancel 16 out of it. So we have 0.5. We have 0.5 raised to power of what? 16. And we have 0.5 raised to power of what? 4. Okay, raised to power of 4. Okay, so from here we can engage our calculator. From here we can engage our calculator. We can engage our calculator. All right, let's multiply the product of 20. All right, we have 20 times 19 times 18 times 17. All right, times 17, that will give us what? That will be 116,280. 4 factorial will be 4 times 3 times 2, alright, which will be 24. 4 times 3 times 2, which will be 24, times 1 as well, right? 24. Now 0.5 raised to power of what? 16. 0 power raised to power of what? 16. That will be 0.0000015 alright, times 0.5 raised to power of 4. 0.5 raised to power of 4, that will be 0.0625. 0625. Okay, 0625. Now from here we can use our calculator. We can find our total, the product of everything. All right, then you can find product of everything. 116,280 divided by 24, that will be, 4, that will be 4845. That will be 4845, right? There's no point writing it, just do everything all together. Times 0.0000015 times 0.0625. So from here our probability, so equals to, where our probability is equal to 0.0045 approximately. Okay, approximately, that's for 16. That's for 16. We found for 15, and now we found for 16. So now we have to find for 17, 18, 19, and 20. Still the same way, nothing changes. The same way, right? Still the same way, we are still going to be engaging the formula. All right, we are still going to be engaging the formula. So let's find for 17. So let's find for 17. So p 17, that will be n, sorry, let's not use n, let's go direct so that we won't take more time. That will be 20 times 19 times 18 times 17 factorial, all over 20 minus 17, that will be 3 factorial 17 factorial. This cancel this. So now we have 0.5, we have times 0.5 raised power 17, 0.5 raised power 3. Okay, so now we can help ourselves out with the use of our calculator from here. So the calculator, we can find 20 times 19 times 18. Just apply your calculator, so you get the probability of 17 to be 0.00103. At the same thing, probability of 18, you put it in formula, you get your probability of 18 to be 0.0018. You do the same thing for probability of 19, and exactly the same thing for probability of 20. Now you have to find probability of s greater than or equals to 12. So you simply add your probability of 20 to your probability of 19 to the probability of 18 to probability of 17 to probability of 16 to probability of 15 to probability of 14 that you found to probability of 13 and to probability of 12. Okay, to probability of 12. All right. So when you do this, what you are going to get is a what? Is the probability of s greater than or equals to 12. And when I press this on my calculator, I get is 0.917, which approximately, and in percentage we have 91.7%. This bring solution, this question to an end. We have successfully solved this problem. I believe this is well understood. All right. If this is the first time you come into my channel, feel free to subscribe to the channel, comment me if there's anything I do here that you don't understand very very well. Feel free to engage me. You find my phone number attached to my video. All right. With that, we call this we bring it to the end of this question. All right. Our further problem will be solved on this channel. You can check them out. And if you need a recap of all I've discussed so far, check back from the earlier video. We started from probability distribution, which is important for you to understand. And um all right, let's just end it here. We continue in the next video.